Good morning, good afternoon, good evening, wherever you're hailing from. Welcome to a very special episode of OpenShift TV. This is the KubeCon office hours implementing GitOps, run by the wonderful Josh Burkus from the Red Hat Open Source Program Office. Thank you, Josh. I'll hand it off to you now.
Thank you, Chris. So for this hour, which is KubeCon adjacent, accompanying KubeCon, a lot of people are looking at implementing GitOps-based workflows. A lot of tools are being discussed at KubeCon for GitOps-based workflows. But, I work a lot with customers and users in the open source realm, and I find that a lot of people aren't quite sure what GitOps means in real life. And so we have here the Red Hat GitOps crew to answer your questions. In addition, this is kind of a joint event with the GitOps happy hour. Now, it's still morning where I am, so I'm drinking espresso here rather than maybe an aviator or a sidecar. I'll wait, I'll hold that until later on. But in the meantime, we will learn all about GitOps. There will be, the team will have a short presentation for folks. They have a couple of demos queued up that they can show you. But please go ahead and ask your questions in chat at any time. And I will queue those up and make sure to ask them on air to the crew so that they can answer them. And if we do use your question on air and you live somewhere that we can ship to, you are entitled to an OpenShift t-shirt. And I will give you information on how to claim that later on. So with that, folks, if you can introduce yourselves. Siamak, you want to start?
Sure thing. I'm muting myself. I'm Siamak Sadeghianfar, product manager at Red Hat, and I run our DevOps and GitOps portfolio on top of OpenShift, working very closely with some of the gentlemen on this call. Excited to talk to you about some of the activities that we're driving, specifically on GitOps.
Christian?
Yeah, so my name is Christian Hernandez, technical marketing manager at Red Hat, and GitOps enthusiast, right? So I'm very, very excited about getting the minds together in this special edition kind of mesh KubeCon office hour / GitOps happy hour. So yeah, I'm excited to work to take some of the conversations that we've been having internally and kind of just bring it out and make sure we answer all you guys' questions.
Okay, Shubhak?
Hey, hi. I'm Shobhik Bose. I'm a CI/CD architect at Red Hat. I work with a bunch of tooling to ensure developers are successful on OpenShift, and I'm very excited to talk to you all.
Okay, and Jimmy?
Hello, everybody. My name is Jimmy Alvarez, and I am a technical marketing manager here also at Red Hat, mainly focused on ACM, or Advanced Cluster Manager for Kubernetes. Great pair up with OpenShift as well as GitOps. So excited to be here today.
Okay, and why don't you take it away with the presentation? And in the meantime, again, attendees, please ask your questions in chat.
Sure thing. So let me go ahead and share my screen. All right, implementing GitOps. I wanted to talk a little bit about what GitOps is and how we see GitOps in the ecosystem of Kubernetes before jumping into more exciting stuff that my colleague is going to walk you through with some demos and some interactive conversations, hopefully down the line. So before I get to GitOps and where it comes from, CI/CD is hopefully, a lot of you are familiar already. A lot of the teams that I talk to have already established a CI process at least in their organization, especially if they are building application. They are from the app side of the house and they are application teams. And CI generally refers to those series of steps that an application goes through, or changes go through from the code till you release an application. And continuous delivery, the more advanced form of that expands it to deployment all the way to various environments. And there are a lot of ambiguity in how people refer to CI and CD when they want to talk about these concepts. CD really applies to the entire process, right? So sometimes when people talk about CD, they refer to that right end of the spectrum of just the deployment, and sometimes we refer to it as a whole as the entirety of this process. So for the sake of this call today, what I mean by CI is that left part of the spectrum that focuses on releasing application, and CD focuses on the right-hand side, just the deployment, so that we have the same terminology that we're going to use to the rest of the call, rest of the session. And the reason I make this separation is that when it comes to technology and tools that helps various teams to set up these kind of processes, you generally need different type of requirements, different type of capabilities within these two phases. Although a lot of tools are used across the entire spectrum for CI/CD, Jenkins being the most famous one of those, they usually lack features for one side of it. There are tools that are more focused on the CD and help you to do more advanced CD processes, and tools that are more focused on CI. And how does GitOps come to the picture? And GitOps is really one way of implementing CI/CD. It's one form of continuous delivery. It's a very developer-centric approach to continuous delivery because it's building on a process that has been for a long time used within the software developer teams for developing software. It's built on the very simple concept of treating Git as the single source of truth for everything related to your infrastructure and application. So everything, absolutely everything that describes your application and infrastructure needs to go into this Git repository as a single source of truth, and you drive your operations through the Git processes. So if you want to make a change in your environment or deployment or infrastructure, that generally is represented as a commit in one of those Git repositories. It usually comes as a pull request that gets reviewed by the team and other members and gets discussed before it gets to the repo. And once it's in the repo, then there are processes in place that make sure that kind of change is reflected into your application or infrastructure. And like I said, this is nothing new, really. This is how we develop. We have our source code in Git repositories usually, and we have feature branches and pull requests. And Red Hat is heavily focused on open source project. Every single open source project that I'm aware of is following this exact same process. The idea of GitOps is expanding this to operations, driving operations using the exact same familiar concepts. And why would we do that? Why would we implement continuous delivery through GitOps? Because there are a couple of benefits that are very hard to achieve when you are relying on other ways of implementing continuous delivery. The first one is really visibility and audit. So what you see on the slide is not really in order, but the importance, from my opinion, is that visibility and audit is something that is very difficult to achieve in CI/CD because of the variety of different tools that are usually present in this process. It's not a single tool. You often have an array of different type of tools that you rely on for security, for automation, for deployment, and other things. And it's very difficult to have visibility across the entire thing. GitOps relies on Git as this single place that you have visibility across everything. So every change that goes into some environment has to be represented as a change in the Git repository. So you rely on the traceability that a Git provider gives you. It also increases reliability because you know that every time that you get a new environment or new deployment, the output is going to be exactly how you have described in Git. It's repeatable, it's predictable. It also enhances security really because GitOps is not only that your state of Git is reflected to the cluster, but also looks at it the way around. So you want to make sure that the cluster doesn't deviate from what you have described, declared in your Git repository. So you make sure that if a cluster deviates for whatever reason, because somebody manually has changed something on the cluster, or a large change, maybe a system is compromised and a cluster changes, deployment changes, the image that is deployed changes, then you will immediately get notified and know that through your CD process, because you know that there is a drift from the Git repository, you can react on it. So there are a lot of benefits on relying on proven processes and the value that a Git provider, Git-based processes provide to driving operations, that implementing DevOps through GitOps really enables those kind of capabilities to be applied to your operation side as well. So how would that look like if you're implementing CD through GitOps? The CI part is what you would expect. So you have source repository, you have a CI process in place. I'm oversimplifying here, obviously, but there are a lot of stages in between till you have released your application. When you've done that, then there is another repository. I'm making an assumption here. This could be the exact same repository that contains all the configuration of that application and the infrastructure that this application runs on it. And you have a CD process in place that syncs everything that is in that repo to the cluster, make sure that the cluster comes to the state that you have desired in your Git repository. So far, this doesn't look that different from how people have been doing CI/CD, perhaps even using Jenkins, right? This is quite similar from 30,000 miles up. But if you look deeper, what GitOps advocates is really this GitOps loop that you don't only deploy or sync the state of the Git to the cluster and forget about it, but rather you constantly monitor the state of the cluster, identify drifts. So if something changes on the cluster or changes on the Git repo, both ways, you would know that the system is out of sync, detect the drifts, and be able to take action upon it, automatically correct it if you want to be always in sync, or perhaps notify an admin to look into it and really make sure that you have full control over the state of your clusters. This is also extremely valuable for multi-cluster environments, right? Because from the CD process, it doesn't really matter if you have one cluster as a target or 10 or 50 of them. You have the same configuration push to these environments. I realize that I talked a lot about application delivery, but also I talked to a lot of teams that are interested in employing GitOps practices for only infrastructure configuration, which focuses really on that lower part of this diagram, that they only have configs that relate to the Kubernetes or OpenShift cluster itself, how you configure the cluster, and you have a CD process that makes sure that the clusters are always in sync. On OpenShift, there are three distinct offerings that really maps to this GitOps process, and they enable different parts of a GitOps-based application delivery. There's OpenShift builds that automates building images on the platform, so you don't have to have local tools constantly installed, and you build your images in the same exact same environment that the application runs, similar to the production environment. There are OpenShift pipelines based on Tekton pipelines that enable CI. Kubernetes, a native way of doing CI, so it really builds on top of Kubernetes concepts for implementing CI. And there is OpenShift GitOps based on Argo CD that enables that full GitOps loop and making sure that you can sync Git repos directly to the cluster and always stay in sync within that model. So these are what you get out of the box. And of course, within OpenShift, we partner integrate with popular DevOps and GitOps tools to make sure that the other tools that a lot of teams use can be integrated into the platform. If you're using GitHub Actions, for example, or GitLab Pipeline as your DevOps, you can directly integrate through those kind of frameworks also in OpenShift and drive your GitOps process. How does that map so those offering to the model that I mentioned? So OpenShift pipeline, OpenShift builds focus really on the CI, and OpenShift GitOps in the lower part that enable you with a GitOps process, with the syncing to the cluster. All the three together give you a base, a foundation for implementing the end-to-end GitOps process. If you look at those stages of continuous delivery and continuous integration, those are also builds and pipeline on the left-hand side, and GitOps, OpenShift GitOps with Argo CD focuses only on the syncing part, on the deployment part, and it does not really help much for the CI. And this distinction of tools really has enabled teams that are implementing GitOps and OpenShift to really take advantage of, for example, on CI, that workflow based of application delivery that Tekton enables. So have a very extensible way to build pipelines, and on the CD part, focus really on a state-of-the-art sync process that it can't do the workflow-based type of functionality, but it does a great job at making sure that your clusters are all in sync with your Git repos at all time, identify drift and correct it for you if you configure it as such. And with that, I'm going to ask my colleague, Jimmy, also to talk to us a little bit about advanced cluster management for Kubernetes at Red Hat.
Yeah, thank you, Siamak. Appreciate that. So yeah, I mean, to continue on with the story here, obviously, you know, having this pipeline building through CI/CD, having OpenShift right? We also add another layer to this, which is Advanced Cluster Manager for Kubernetes. And this tool really helps you not only manage the lifecycle of all of your clusters, but it does much more than that. We can integrate from the application deployment engine directly into GitHub to make sure that all of your application deployments are driven and following those same best practices. So you can just directly integrate, pull your code directly, make changes, update them, right, and continuously keep that that process going within your applications. Of course, we can also do policy-driven and governance, risk, and compliance on top of all those containers, and multi-cluster observability with Grafana. So we can actually graph out all of your clusters to bring visibility into where there might be some issues with your applications if you wanted to look at and troubleshoot problems. So Advanced Cluster Manager for Kubernetes really is a great tool that just helps kind of bring it all together by extracting some of that management directly from the OpenShift platform in the console to this product that really helps you, like I said, not only visualize it, but also allows you to build your application. Next slide. And so, just wanted to kind of quickly graph out and show you guys how this process kind of works, right? So obviously, we talked a little bit about having multi-clusters, right? And deploying those multi-clusters across multiple different environments. So the idea here is to have, advanced cluster management for Kubernetes. We leverage a concept that we call subscriptions. These subscriptions they can be directly to GitHub, or they can be to Helm charts, anything in between, right? But taking GitHub as an example, we subscribe to that specific channel which contains my code, right? And then we can take that and propagate it across all of the clusters that are being managed directly from an ACM perspective. So making it very easy, very simple to maintain, making it also super simple to kind of make changes. So if you wanted to go and push a new change, perhaps to a dev cluster to test it out before you go into production, the process is very easy. You can just go back, edit your application, deploy it, or even deploy a new cluster to test out that application in Dev or QA. So everything is all managed directly from Advanced Cluster Manager for Kubernetes as a subscription models, subscribing to that, that channel from within GitHub. Next slide. Same thing goes for local subscription flows. If you wanted to do that, again, it's all driven the same exact position. So Advanced Cluster Manager for Kubernetes can run in a completely isolated environment, and you can actually push from a local Git repo. You can push all of that directly into it, and of course, to all your clusters. And that's it. Simple as that.
Cool. Do we want to break for questions, or
yeah?
Josh, what do you got for us?
We have our first question. So Lily wants to know GitHub Actions. How does GitHub Actions integrate with all of the tools that you have here, if at all?
Yeah, I haven't worked with GitHub Actions directly. From what I understand, it's a CI/CD. It's like a CI, another product, kind of like Jenkins. I don't know, Siamak, Jimmy, or Bose, if you guys worked with GitOps.
Sure, I can talk about it a little bit. GitHub is actually a very good partner of ours, and keep an eye on GitHub Universe. That happens, I think, in 2 weeks or 3 weeks. So there's going to be some more news about this as well. But GitHub has CI functionalities added to a long array of capability, developer-focused capability that they have around the repository. So workflow and CI is one part of that. You have this YAML syntax to build CI functions and execute that as a part of the events that are generated in that Git repo. And GitHub Actions are similar to plugins, that there are these units that you can put in your workflow and compose different type of things. So there are GitHub Actions for, let's say, deploying an application on Kubernetes, or scanning your image, or run a Maven build, perhaps, for application. So we do have customers and that really like GitHub Actions, and especially when it comes to the GitHub CI would come to GitHub Enterprise. We're expecting that more and more users going to start using it with enterprises as well. So because of that, we are actually working on, there are already a number of GitHub Actions that you could put in your GitHub workflow, and as that workflow executes, you can interact with an OpenShift cluster. So deploy an application to it, get a status, roll out a new image, and so on. And we are working actually to expand those number of actions so they can automate a lot more of those kind of activities directly as predefined units. So perhaps not only just run a command against OpenShift, but be able to roll out a new deployment, but just providing the name of the deployment. And you build the image through the GitHub workflow and pass that name of the image to the GitHub action that can integrate with OpenShift, and that redeploys the image on OpenShift. So we are collaborating with GitHub to identify some of these actions that gets requested a lot by the community of GitHub, and bring more of those into the ecosystem of GitHub Actions that are available for OpenShift.
Okay, so one more question. Martin asked about CentOS and OKD. I guess Martin is asking whether or not, you know, the tools that you've talked about can be run with that stack. If not, they can follow up with a follow-up question. But in the meantime,
yes,
do you know if they can?
Yeah, they can. So that's really that's the DNA of Red Hat, right? So I wouldn't talk about anything that does not have an upstream and open source available on open source. And not only on OKD, these pieces that I'm talking about are really available for Kubernetes. So you can run it on Minikube or any Kubernetes flavor, including OKD. So OpenShift pipeline is really supported Takedown pipelines. So Takedown pipelines can run on OKD or any Kubernetes. The same for Argo CD. The same for Shipwright, which is the project that powers OpenShift build. So all of those are available on all flavors of Kubernetes in essence, including OKD.
Mparam wants to know if anybody's working on, maybe if it already exists, a plugin to handle your secrets. Together with Argo CD, so that they automatically get checked in, new secrets automatically get checked into a secure secrets repository like Vault or Keycloak?
This is actually a very, very frequent question that comes up, but I'm gonna ask Shuvik to chime in on this one. He's been working on this in the last couple of weeks, actually, very recently.
Yeah, sure. Thank you. And I'll let Christian also add into that. So there are a couple of different solutions that we are currently exploring, and one of the things that you will see in my demo shortly is that we have a new CLI for you to bootstrap everything GitOps, which means that in the world of GitOps, you need stuff to land on your Git, and then they would be applied to your cluster and all that. So which means if there is a secret that you need that has to be represented on Git, it has to be, of course, encrypted or referenced. One of the things that we've been looking at is seal secrets. The other we've been using is the SOPs solution. So we're kind of trying out both at this point, but the demo you will see right now in a few minutes is where we have a CLI which depends on seal secrets. Christian, do you want to add to that?
Yeah. Well, just to kind of expand on that, and I think Bozy did pretty good job about it, because I'm a fan of seal secrets. There's this kind of and Bose, you know, during our conversations, internal conversations, is that, you know, there's this kind of gray area when it comes to secrets, right? Because like there's something like Vault that manages secrets, but it's not necessarily GitOps because your secrets aren't stored in Git, right? So the secrets is actually stored somewhere else.
Yeah.
So it's technically not GitOps because it's not stored in Git. I'm personally a fan of sealed secrets. Only because, one, like you're encrypting it, right? And two, usually when you're using GitOps, you're using your own internal Git repository. So you're not really necessarily storing your secrets like on GitHub, right? You're like storing it like, you know, in your own internal Git systems. So there's less you have many layers of security there, right? Like you're behind a firewall, right? It's password protected, and on top of that, it's encrypted, and on top of that, you're rotating it, and on top of that, you're doing XYZ, right? So I'm a fan of sealed secrets. Not to say that none of the other solutions aren't valid, right? Because like Vault it's a secret management system, right? So you kind of you have to weigh some of the things, like you want to manage your secrets. You want something to manage your secrets, or do you want to manage your secrets yourself, except you encrypt it? So it's still an exploration, sort of process.
So it's like you either encrypt it and store it on Git, or you use a way to refer to it while it is actually stored somewhere else. So yeah, there are these two options that we have out there always. Yeah.
And I do agree with Christian on that. Like a lot of teams I talk to, and they ask this question when I ask, so what are you doing right now? And the answer is exactly what you described. They're just putting their secrets in their internal Git repos, right? So it usually comes as a very sensitive area that people look for something like really elegant to solve the problem. But in the meantime, all the secrets are in the Git repo in plain sight, really.
Okay, well, given that this ties into the demo, why don't you go ahead and go with the demo and show people?
Awesome, thank you. Let me share my screen. Yeah, so welcome to the demo of GitOps Application Manager. A few things that I would touch upon here is, first of all, how do you actually execute GitOps or CI/CD, or even the stuff that we were talking about, which is maintaining your secrets in Git so that you can have truly everything in Git. So I'll touch upon those topics in this demo. And in this demo, what I'll primarily focus on is what is the promised land with respect to GitOps, and then also tell you how some of the work that we are doing is helping us get there. So a very basic question: what would you as a developer have with you to begin with? What you would have is your source code, of course, because that's the stuff that you built. That's your business application that you now want to have deployed on some Kubernetes environment or some environment. Now, what you need for that? For that, you would need deployment manifests, because that's what actually takes your code and ensures that they can run on a cluster. And since we talked about maintaining them on Git, you need some kind of PR checks or branch verification. So you'll need pipeline manifests as well, which means you need your deployment scripts and you need pipelines. And of course, with this, you're good to go. But then the next question is, how do you lay all that out? Because there could be a ton of different ways to do that. There could be amazing ways to do that, and there could be not so amazing ways to do that. So which is why we are working on a CLI that would actually enable you to structure all this in an opinionated way, and ensure that you don't have to worry about figuring out what is the best way to lay that out. Rather, you can only focus on, hey, I've got an application and I know I need CI/CD. I know I need GitOps. I know I need secrets encrypted. Now, what is the best way to maintain that and have that applied on the cluster? So what I'm going to do is I'll quickly go over, what the CLI looks like. So the CLI is called GitOps Application Manager. It effectively generates manifests for your pipelines. It generates manifests for your CD or GitOps. And it also does all the job of getting your secrets encrypted before you can push them to Git, which means you should not end up in a situation where you push something to Git and you realize it wasn't encrypted. So yeah, a quick look at what the commands look like. So you have a bunch of different commands, but they're effectively all about bootstrapping your CI, your CD, creating a new environment in GitOps. And in a while, I'll get to that, what's the difference between an environment or an application or a service. And then you could also directly manage your Git webhook from this CLI. One very clear distinction between why the CLI exists and what you can do without the CLI. The job of the CLI is not to deploy things on the cluster for you. There are a bunch of CLIs for that. The job of the CLI is to scaffold all the content that should eventually land in your Git repo so that you do not apply anything from your local file system. Everything should get applied from Git. And when I say everything, I mean everything. So you need pipelines. Sure, that itself also should be maintained on your Git. There's a lot of content here, but the good news is the CLI makes this all boring, which means you don't need to learn Tecton, or you don't need to learn anything Kubernetes specific to be able to generate your pipeline manifest. You just need to express an intent of what you need to do. And then I said that you need to deploy stuff to your cluster in the end, so which means we're using Argo CD for this. The CLI also generates that for you. And you could see that there is a folder under config, which is called Argo CD. A few minutes back, I think you asked a question around secrets. Thank you for asking that. And I'm so happy to show you that I got a bunch of secrets here on Git, and they're all encrypted. I didn't have to do much with this. All I had to do effectively is have sealed secrets installed on OpenShift as an operator. And then the GitOps application manager CLI automatically knew that it is there, and it went ahead and generated manifests where I have an encrypted secret, so that I didn't have to bother about encrypting it myself or figuring out what that even means. So with that, I'm going to quickly give you a walkthrough of what a typical GitOps repository should have. So it should, of course, have your applications manifests, which means I have my source code, but I do not know how to deploy it on OpenShift or Kubernetes. All that should be living on your Git as well. So the CLI bootstraps that for you. In this case, you would see it potentially assumes that you would have a dev prod stage at the minimum. You could change these names the way you want it to be. And inside each of these directories, you would have a layout that would indicate the stuff you want to deploy. So in this layout, which is an opinion which the CLI gives you, is that, hey, you need to have an environment. Inside that you specify an application, and inside that application you specify which are the services that you want to deploy. And one of them is called the taxi application, taxi service, and there are a couple of Kubernetes manifests inside it. Now, once again, did I handcraft this myself? No. All I did was use the CLI for that. I'm going to now show all of this in action. And by that, I mean, I'm going to actually make a pull request to this repository. So if you remember the whole GitOps flow of doing things, which means you don't make any changes to the cluster. You only make changes to your Git repo, and you ensure that all your governance lives in your repo. And when you merge things in Git, you want to ensure that stuff gets reflected on your cluster. So that's what I'm going to do here. So for that, just so that you know I'm not bluffing, I'm going to have my OpenShift console open. And please let me know if my screen is too big or too small. I can adjust that. Then I'm going to go ahead and modify a manifest that I need to get redeployed on my cluster. So I'm going to go to the deployment manifest. I'm going to say, hey, this looks like this one replica defined here. I'm going to make it 4. I'm going to put in a nice message here. Bump up replicas to handle holiday traffic. And I'm going to propose a change for that on Git. And as soon as that branch got created, or the pull request got created, you could see that I have a pipeline running here already. I did not trigger that manually. Just as soon as I did that, this triggered a Tecton pipeline. I'll go back to the same old question. Did I write these manifests myself? No, the CLI did that for me. I'd say succeeded. What it did is it ensured that I didn't make a change that was illegal, which means the change is legal in the Kubernetes world. The change is something that could potentially go in safely. And I'm going to go ahead and merge this because I see it succeeded. And then I'm going to do a merge. Before I do that, I'm going to show you here that here's a previous state of the deployment with 1 replicas, which I showed you, which I modified to 4, and I made a pull request to it. I didn't merge it to master directly. Why? Because I wanted somebody on my team or somebody to tell me, hey, this looks good. Let's take the change in and get it applied on your cluster. So I'm bumping up replicas to handle the holiday traffic. Let me have a nice commit message, and I'm going to go ahead and commit it. And let's see if things get pulled in while that happens. So very shortly, you should see that I've bumped up the number of replicas from 1 to 4. The number of pods on the left should quickly change. Yeah, as you could see, the moment I merged my PR, which had changes to my deployment environment, the changes got pulled in, and I've got 4 replicas of my application running to handle the holiday traffic. So what did I just accomplish? As a quick summary, I opened a PR, it ran a CI pipeline, which is Kubernetes native, and then I merged it, and I finally have stuff changed automatically, which means I did not have to apply this change on the cluster manually and have to handle some ticketing system to keep an eye on it. All I did was I went into Git, I modified it. So if somebody comes by and say, hey, you know what? Find me the guy who went and modified this. All you would have to do is go to your commit history and see who managed this. I could totally go and revert this commit and say, hey, I'm done with 4 replicas. I could just go back to 1. That should be good. So now the problem that we've been solving is, hey, this is all cool, but then, I've got thousands of applications, thousands of services. How do I do that? And one of the things that we're working on for that is effectively CAM that helps you set all this up without you having to reinvent the wheel. And once you do that, the interesting bit is that now you're not only managing your application from Git, you're actually managing everything on Git, including your pipelines, which means if you want to modify your pipeline configuration, you don't come to the cluster as such, but you could directly go to your Git manifest, tweak your pipeline, and ensure that Argo CD syncs that in for you. So the same thing is happening for Argo itself, which means if you want to modify your Argo configuration itself, which is doing all the heavy lifting of continuously deploying your stuff from Git into your cluster, you would also do that on Git and ensure, everything gets synced onto your cluster. And at the same time, you would see I have got my 3 different copies of the same application running in 3 different environments, as I've said, a dev environment, a stage environment, and a prod environment. So with Argo CD, I'm going to ensure that everything that's on the cluster is going to remain synchronized. Tecton pipelines is going to ensure that I have a Kubernetes native pipelines. CAM is going to ensure that all this that you want to, all this niceness that you see here is going to be bootstrapped for you and managed on Git without you having to figure out how to do that. With that, I'll stop. I'll pause and check if you have any questions.
Okay. You want to stop sharing there for a minute?
Sure. Yeah.
Cool. So we've actually had some questions to come in. A lot of them have to do with secrets and encryption. But before those come in, Martin had a follow-up question asking what's the actual difference between for these tools for Argo and OCM and other things in the upstream. What's the actual difference between those tools and the enterprise versions that are available from Red Hat? I'll actually start.
But yeah, I guess.
Go ahead.
I guess. Yeah. So I guess I'll just start. Really, the only difference is that you get support from us. Since we use upstream code a lot, right? Where Red Hat has always been the open source company. So it's really the difference is that you can call us. But I'll let Shubik and Siamak expand on that.
Yeah, I think you're spot on, Christian. we have teams which work upstream in the Tekton community. We have teams which work upstream in the Argo CD community. So 100% of the code that we write is on upstream itself. The only bit that we do is to ensure that, hey, there is an amazing OpenShift pipelines operator that ensures that Tekton is well managed in your cluster. It is lifecycled across versions of OpenShift. We are doing the same thing with Argo CD as well. And of course, on top of that, we would provide guidance to our users and customers to say, hey, this is the best way to do that. And most of the guidance is something that we also contribute upstream as well. But then that's pretty much the only difference there, that we want to ensure that across different versions of OpenShift, there's a good way to lifecycle these technologies that we endorse or we recommend you to run on the cluster. Siamak, do you want to add to that?
No, I think you're exactly like the gist of it is really that our focus is to drive this technologies upstream. Everything we do goes there. That includes all the fixes, bug fixes, patches, and those kind of thing. And our focus is to make sure that they run really well on OpenShift, provide a great experience for users that want to build applications and deploy them and manage it on top of OpenShift. And I think this is something that this is a great role that we can play within this community as well, because a community usually will, if you look at Argo CD or Tekton itself, for example, is very focused on that particular tool, but we can look at the use cases that our customers have, and it's usually touches many of these tools together because they're out there to fulfill a purpose. They have a goal in place, and they're using multiple combination of these tools to achieve that. So it gives us a way to look horizontally across all these tools and make sure they work well with each other to achieve that purpose and that goal.
I do want to mention one exception to what people said before, because we did use advanced cluster management mentioned it in the first presentation. Advanced cluster management has not been 100% open sourced upstream yet. We are in the process of making all of that code available as an independent upstream project. But it's not done yet, and it'll be happening over the course of this year, pretty much.
Yeah, I'm glad you mentioned that, Josh. Appreciate that. I was about to say the same thing.
Yeah. Well, and also, kind of just to remind everyone, anytime Red Hat either acquires something or gets some sort of code, we want to immediately turn it around and open source it. It just takes time, right? Because some things can't be open source. And
Yeah, and on the flip side of that, I mean, we do have a Git repo available with all the code there. So we obviously, we're still working through the process to actually make it fully open source. But we do have a repo out there with most of the code for ACM.
Yeah. Okay, so we then have questions both from M3 Addo and the Second Son about secrets and encryption. M3 Addos has to do with storage of the secrets on the cluster. That is, how are they being stored so that they're actually encrypted and not just hashed? What solution to use there? The Second Son, and this might be a related answer, wants to know about automated key rotation for the keys used to encrypt the secrets, particularly in a multi-cluster situation.
Yeah, I'll start that just only because and by the way, Chris, thanks for posting the link to my previous stream about secrets. That's on the chat. So the first and foremost, and I think Chris, you put a good link in the chat, is that you can encrypt the etcd database, right? So not only can you encrypt the actual etcd database, you can actually encrypt the disks that they're on, right? So you're adding a layer and you're adding another layer on top of that, and then you actually used sealed secrets, right? Instead of storing them in base 64. And so so then you have kind of like a triple layer, right? Like security, all it is just layers, right? Of like how many barrier of entries that you have. So yeah, so that's kind of like one of the solutions is that you're encrypting at every step, right? You're encrypting the disks. You have etcd encrypted at rest, right? And then you're using either sealed secrets or vault or something to encrypt those secrets. To kind of expand about the rotation, sealed secrets does rotate the encrypting key, right? But it doesn't get rid of any keys, right? So like it'll rotate the key, but the old key is still valid, right? It'll keep rotating the key anytime you encrypt it. It's actually up to the end user to re-encrypt your secrets with the new key before deleting the older keys. So that's one. And two, make sure you're rotating the username and passwords. This is something that we kind of went over in depth in my previous stream, right? So I won't go too into depth here. But really that goes back to the conversation of like managing your secrets versus just encrypting it. And there's really no tool that does both, right? So you do have to kind of like if you're using sealed secrets, you kind of have to self-manage the rotation and re-encryption. So I don't know if any of you guys want to add to that.
No, I think that sounds perfect. I think you're good.
So we have a completely different question, and I'm sure we'll get follow-ups from other people on secrets, etc. Also, I wanted to point out that posted in the chat is a link to a previous GitOps happy hour specifically entirely on the topic of secrets that has a lot more information. And this question was off of the demo, which is that the question that F. Glazer has is the PR decorations, do those run a customized CLI to check the files?
No, so it actually did a dry run to ensure that everything works there. So it's not a customized CLI. It effectively does a few things, which is it ensures that all the manifests that you have on your Git repo is still valid after you proposed a change to it.
Kind of like a pseudo lint, right? So you kind of linting, making sure.
Correct. Yeah.
Cool. I think we have one more demo unless there's more questions, right? I think we got the ACM. Is there any?
Yeah, we don't have any pending questions, so go ahead and go for the last demo.
Yeah. Okay, great. Awesome. All right, so let me go ahead and share my screen here real quick and quick verification that you can see it. Awesome. All right, yep. So what what we saw earlier, right? Obviously, we saw it working and interacting from a Git perspective with OpenShift, right? And so what I wanted to do is extract it one more layer. And so, with advanced cluster management for Kubernetes, we have several other use cases that we can talk about, but I'm just going to focus today on the application lifecycle. In the application lifecycle, what this allows us to do is build applications using what we call an application builder. You can see here towards the right that we have the actual application YAML as we're building our application. You can see that we can assign a very specific namespace to this application, right? So we're deploying this application right on top of OpenShift. As a matter of fact, Advanced Cluster Manager for Kubernetes runs on top of OpenShift, right, as an operator. And you can see here that we have different repo types that we can select for. So if I can select my Git repo, all I have to do is provide things like a URL, username, access token, branch, path, right? Pretty straightforward type of information here when I'm building my application. So say I want to build an application for with my Git repo. What this is going to do automatically is going to go to the specific Git repo, which I'll show you guys in a minute, pull all my information based on the branch that I select. In this case, I'm going to select actually my Hugo branch, and I'm not going to select the path. I don't have any path available, but you notice that we had that very easily as a drop down to consume from within ACM. So this just extracts it one more layer for enabling your operators to perhaps deploy these clusters directly, right? And once changes are actually made within the Git repo, you can merge them directly into ACM. We also have integrations with other third-party, with other tool set within Red Hat, which is Ansible Tower. So Ansible Tower, with Ansible Tower, we can integrate and run playbooks to do even more interactions with other products, right? Like, for example, opening a change ticket with ServiceNow or doing an F5 load balancer, things of that nature. We can also deploy these to specific clusters, or you can deploy to clusters based on labels. So we can create specific labels that only exist on specific clusters and deploy it there. We can also set a deployment window when we want this application. So perhaps if you're doing testing for this application, right, you can actually have a very specific window that you are allowed to do the testing in, or even perhaps deploy a change into production. You can select it, of course, based on days of the week or location, times, etc. In this case, I'm going to just do always active. And so while this application is building, I'm going to go ahead and navigate to this other application that might seem very familiar to some of you. So this application is just a Pac-Man application that we have built. Yes, it is the Pac-Man game. You can see here that I have a subscription, as we talked about earlier in the slide deck, right, directly to my Git repo. Now, notice if I go ahead and click here, it gives me the URL for the Git repo, as well as the branch and the path that we use for that, right? So I have basically direct access to my Git repo. I can make any changes here, so I can go ahead and edit any of this and actually push it back into my application, and automatically ACM will pick this change within the resource topology, right? And push that change. You can also, of course, using labels, leverage the power of deploying into multiple clusters. So right now I'm deploying this application into 2 specific clusters. I have also an Ansible job that I ran to do a pre-hook and a post-hook for the 2 very specific things, one for ServiceNow, another one for an F5 load balancer, right? And you can see here at the center of it is all within my subscription, right? Which is, again, the way we interact with Git. You can see, of course, all of that resource YAML right here of the actual deployment and how the deployment was done. You can quickly go and edit that if you wanted to, and alter it and change it to do that as well. So there's several ways that you can interact and also kind of work with within Advanced Cluster Manager for Kubernetes to actually deploy your applications. In this case, I get a route for this specific application. You'll notice that I can go in and actually go out and play my Pac-Man game, right? Pretty straightforward. Notice here that I deployed it into 2 different clouds. So I have this deployed into Amazon US East, and then I have one deployed on Amazon US West. So since this is load balance, I can go and if I refresh, it will switch clusters. I can also look at the specific route for each individual application. So you can see within each individual clusters, right? So you're able to actually see all of these resources right from here. So it's very simple, very easy way to kind of visualize, manage your application, right? Directly from Advanced Cluster Manager for Kubernetes, while consuming it from your Git resources, right? As we saw earlier, I can come in here, I can make a change to my spec within my application. Notice here that this is just a basic YAML deployment that I have that have things like the channel. It has my subscription type. It has my placement rule, right? So my placement rule is where I'm going to actually place this cluster, right? And you can make these changes and all consume them directly from Advanced Cluster Manager for Kubernetes. So it's really easy, very simple, very straightforward to kind of manage all of this. You can, of course, manage all of your secrets for your specific clouds within ACM as well. So all of your clusters, whatever they might be on-prem or they might be on other clouds, you can manage all of those contents and resources there directly. So pretty easy, pretty straightforward way of consuming your Git repos within Advanced Cluster Manager for Kubernetes. It just simplifies some of that interaction that's needed, right? So, and that's pretty much it, what I have for you guys to kind of show you around Advanced Cluster Manager for Kubernetes and application deployment. Any questions out there?
Yeah, I don't see any questions coming in. And by the way, great timing, Jimmy. That's like we have 5 minutes left to wrap up and answer any questions. So it's almost like we timed this perfectly.
I know, right? That's funny.
yeah. I love it when a plan comes together. Yeah. So there's no questions coming in, but I think I do like to point out in both demos that no one, either Shubik or Jimmy, they didn't touch the cluster, right? So, and I think that's very important to come into light, right? I think that's just the general GitOps ideology and practice. I always refer to a talk I saw long time ago when Kubernetes was just a name. Kelsey Hightower, you guys may have heard of him, was talking about, was trying to explain Kubernetes and the design of Kubernetes. And he said, like, how do you design he described it as Kubernetes is a system designed if I took your SSH keys away, right? And I think with GitOps, where, the idea is like, okay, well, now I'm taking away kubectl from you, right? So, it's going that extra mile, going a step further, is like, okay, well, if I'm taking away your not only your SSH keys, but also your kubectl and your OC command CLI, right? So kind of a bold thing to state, but it's kind of like, that's the idea, right? Neither Shubik nor Jimmy actually dropped into the command line or actually even interacted with the OpenShift console, right? They were driving everything through Git repos and through practices and processes. So just kind of bringing that to light, and that's kind of like the power of GitOps, right? Whether you're managing your application, right, with a CI/CD, or you're managing multiple clusters and you're trying to deploy your applications through multiple clusters, you're driving everything with practices, right, and tool sets. So I don't know if any other questions came up, Josh, while I was pontificating there, but.
One last question, and then we will have to wind up. Andrietta wants to know the OpenShift documentation around CI/CD is all written as by a command and control format. That is, send this command, send that command, instead of declaratively, which is more your sort of GitOps centric approach, where you say, define the file and then it gets automatically synced. And wants to know whether or not anybody's working on the documentation to incorporate more of the declarative approach.
This is absolutely so. This is definitely something that we have on our radar. We have recognized this since a couple of releases back, really, that our documentation really does not reflect how declarative the platform itself is. We have spent about 2 years making the entire platform declarative, right? So everything, like out of nothing, you can just out of a Git repo get to, and with the inclusion of ACM, get to a cluster running up with all the configuration you want applied to it. But our documentation is a little behind to show this picture. So we do have this initiative that is running, not as fast as we want, because it's very extensive. It's really it was exactly as is asked, that it touches every single page of our documentation, but we are incrementally across various teams within OpenShift engineering, prioritizing that and updating the docs till we get to the point that the entire configuration is also documented as how it can be managed declaratively, and it's just dropped in Git. Definitely on our radar. Hopefully we progress faster than we have done so far on it.
Okay. Yeah, unfortunately, things move faster than we could type. Things just move really, really fast.
Okay, well, thank you very much. We are at the end of our office hours / happy hour. If you asked a question during this, I have posted a link in chat for how you can claim your t-shirt. And we will need to wind up now. If you missed part of this, it's going to be available on YouTube. And the team, when's the next happy hour?
Next happy hour is every other week, every other Thursday. So it'll be not next Thursday, but the upcoming one. So
awesome. And so you can ask more questions there. Thanks, everyone. Great time. Thanks for questions. And thanks so much for the panel for supplying so much information.
Thank you.
Thank you.
Thank you very much.
Thank you, everyone. Appreciate it.